Hello everyone! Let me introduce myself. My name is Candra Dewi and I will be your guide teacher in this video. So, we are going to talk about math, approximately, and today we will learn about sets, relation, and function. Okay, next. Before we start, let's do a brainstorming and build our motivation. Okay, this is the quotes of the day. Math is like going to the gym for your brain. It sharpens your mind. This quote is from Danica Clear. Okay, so we know that learning math isn't just wasting your time, but it's just like exercise for your brain, right? Okay, next. 1. We are talking about sets. Definition of sets. A set is a collection of items that can be clearly defined. An item in a set is called an element, and we say the set contains that item. A set literal is written using curly brace like this, with the elements separated by commas. For more understanding, we have the example of sets. This is the example of sets. A set of the real even numbers around 1 to 20. So we can obtain 2, 4, 6, 8, 10, 12, 14, 16, and 18. Then we have the example of non-sets, like a collection of the beautiful picture, delicious food, great novel, and the other one. So the example above is not a set. This is not a set because we cannot measure adjective noun. That is according to point of view from every person. Like one person said that is good, but the other person can say that isn't really good. Okay. Next, we have notation of sets. Commonly, we will use a variable in capital letter to represent a set. So, it is easier to refer to that set later. Second, the symbol is means is an element of. So, this is the symbol. Third, a set that contains no elements like this empty brace is called the empty set, and it's notated like this. 3. We have subset. A subset of a set A is another set that contains only elements from the set A, but may not contain all the elements of A. If B is a subset of A, we can write B subset A like this, with this symbol. Then, a proper subset is a subset that is not identical to the original set. It contains fewer elements. If B is a proper subset of A, we can write B proper subset of A. Okay. 4. We are talking about Venn diagrams. A Venn diagram is a way to represent each set by a circle, usually drawn inside of a containing box representing a universal set. Overlapping areas indicate elements common to both sets. Basic Venn diagrams can illustrate the interaction of 2 or 3 sets. 5. Cardinality. Okay. The number of elements in a set is the cardinality of the set. The cardinality of the set is often notated as A matrix like this or NA. Next, we are talking about relation. Okay, definition of relation. In a relation, there are no special rules that must be met to match members of the regional association to members of friendly regions. Each member of the regional association of origin can have more than one partner or may not have a partner at all. The relation of two sets can be expressed in two ways. First, with the arrow diagram, like this. Second, with Cartesian diagram. Nah, this is the example of row diagram and Cartesian diagram. Next, we are talking about characteristic of relation. Okay, there is 4 characteristic of relation. One is reflexive. The relation R on set A is reflexive if A, A is element R for every A element A. Second is symmetrical. The relation R on set A is called A set if A, B element R, then B, A element R for all A, B element A. 3. We have antisymmetric. Relation R on set A is called antisymmetric if A, B element R and B, A element R, then A equal to B for all A, B element A. Transitive. Relation R on set A is transitive if A, B is element R and B, C element R, then A, C will be element R. So for all A, B, C is element A. Next, okay, we have the example of relation. Okay, this is the example, the question. There are 4 children that plays Among Us, and they use their favorite color for the name ID in that game, like below. Okay, Mimi use red, Ayu use purple, Benny use black, Julie use red. So, from the description above, we can state the relation with the set of consecutive pairs as follows: Mimi, red, Ayu, purple, Ben, black, and Julie, red. Thus, the relation between set A and set B is expressed as a set of consecutive pairs x, y with x element A and y element B. Okay, the last one, we are talking about function. Definition of function. A function is a relation from set A to set B if each member of set A is matched with exactly one member of set B. The function is denoted by f a to b or f x to fx equal to y. A is called the domain or region of origin from the function f, or written with d, and B is called codomain or friend area of the function f, or written as k, and members of set B who are pairs of members from set A are called ring or results area and written with rf. Then characteristic of function. There is 4 characteristic of function, such as the subjective function. In a function f a to b, if each element in B has a partner in A, or every y element B existed in x element A, so that fx equal to y. And this is the example of the subjective function. 2 is the into function. In a function f a to b, if there is an element in B that doesn't have a partner in A. So this is the example of the into function. You can say that B doesn't have a partner in A. 3, we have the injective function. In a function f a to b, if each element in B has exactly one pair from A. So this is the example of the injective function. Last one, we have the bijective function. If the function f a to b is both a subjective and an injective function, so this is both function is from the subjective function and the injective function. Okay. Next, we have the composition function. If function f a to b and function g b to c, then the function h will be a to c is called the composition function of f and g, or written as like this: each x element f maps gx equal to f gx. So the sample we can read f maps g, and this is the example of the composition function. You can say that function f is from a to b, function g is from b to c, so the function h is from a to c. So this is, we can call this composition function. Okay, we are in the last part of the lesson. Now we are talking about inverse function. If we know that a function f a to b is defined by fx equal to y, which maps x element a to y element b, then the function is called the inverse function f, and is written f power of minus 1 b to a, or f power of minus 1 y equal to x. And this is the example of inverse function. You can say the function f is from a to b, and the function g is from b to a. So this is become an inverse function. Then steps to determine the inverse of the function. 1. You can suppose fx with y. 2. Express x into y. 3. Change the equation until you leave an x of one of the sides in the equation. And the last one, change x to fx and y to x. Okay everyone, thank you so much for watching, and hope you can enjoy the video. See you next time. Bye bye.